Good day, my name is Negin Rasouli. I'm a master's student of Water Resources Planning and Management. I want to talk about the origins, legacies, and shortcomings of the problem-solving frameworks that have shaped the history and evaluation of the water resources management field. This editorial summarizes recognizing the challenges to water management. It is necessary to know that our field needs to elucidate what water management science should be in the future. So we should pay attention to the increasing importance of water in the future and the necessity for the present generation to plan for the water needs of the next. In this vein, much can be learned from the historical criticism of the water resources planning and management provided by Lippmann in three parts. Um, Number one, classical single criterion optimality for complex human water systems decision making has a very tenuous meaning. Um, what does it mean when Liebman said that the optimally is a myth? The top-down, or we can say omnipotent analyst approach to formulating and solving water management problems has severe limitations. The magnitude of the challenges we are facing as water resources professionals, um, it is very important today that we have to move beyond the assumptions of an omnipotent analyst with perfect system knowledge. And this is the effort that Lippmann suggested in 1976. Least cost optimality assumes perfect problem formulations, perfect information and evaluation models that fully capture all state consequences of the future. So the use of deterministic single criterion optimality is not an appropriate focus um, for complex water resources system problems. Even a simple problem and cannot be adequately resolved using a single optimality criterion such as calibrating a simulation model. The technical, cognitive, and computational limitations of too strict focus on the singular optimal solution are reinforced by Climaco in his critique of using narrow mathematical definitions of optimality when balancing technological innovations and its concomitant societal risks. um, Future water resources systems management paradigms must instead quantify wild risk trade-offs, their associated uncertainties, and potential risks that may emerge from limitations in our observation and biases in our predictions. So we have to avoid paradigms in which consequences, compromises, and hypotheses are hidden stakeholders and decision makers. Brill's study indicates that when water resources problems and evaluative criteria or quantitative objectives increase in number, optimal solutions found in lower dimensions are often considered inferior by um, decision makers. It acknowledges the fundamental challenges um, implicit to defining water resource problems, the limits in our understanding of causality in these systems and the complexities associated with characterizing the emergence of risks from the very acts of modeling or decision making that often are unintended. Um, and the second part of Lippmann's criticism that provided is that water is a wicked problem. Um, water resources management problems like single criterion optimality that we talked about it in last part emerge because of their implicit uncertainties, their risks, and the diversity of perspective that define the social value of water resources as retail and I think Weber talked about it in the policy sciences. Um, they contend that water resources planning and management is a class of wicked social value problems because of five reasons. Number one, lack definitive formulations. Number two, um, they are not true or false. For example, judgments can only be subjective, not objective. Number three, they are unique and non-decomposable. Number four, possess decisions that are often um, irreversible. And the last one, number five, we can say that yield a range of consequences and that are highly uncertain if not completely unknown. Um, Generating and judging water resources management alternatives is in reality subjective down to the individual and a legitimate scaling challenge when seeking consensus at institutional, regional or national levels. So we say water is a wicked problem because the scale of this problem is huge and it complicates every other public issue when the water resource management is unsafe. Um, Water issue is tremendously complex. The problems of water are not just technical issues that can be fixed with mere technical solutions such as building a well, installing a pump, or adding sewers. But what needs to be considered is that education, economics, health systems, policy, and governance all play a role. Um, Clearly, our emerging understanding of the water cycle has broad um, implications on how local water resources management decisions impact other watershed systems locally, regionally, and even globally. And it was a study that Maxwell and Khaled talked about it. Um, I think more than 30 years ago, Lippmann warned um, of the risks of the convenient but artificial separation of engineering, science, and policy. Um, Rigorous model evaluations from social, technical, and scientific perspective are vital for future water management frameworks. Number three, the future requires constructive modeling. Defining our problems to be of use in real decision making is a problem in water resources management. Our problem solving frameworks need to advance the collaborative um, construction of management models so that they can be evaluated rigorously from diverse perspectives for their um, transparency, their validity, and the equity of their impacts. The purpose of this editorial is to frame the um, contention and that beyond research funding for water management, there are strong methodological limitations in the traditional ways many water management problems are classified, decomposed, and solved. So it is quite challenging to incorporate state-of-the-art water cycle science into real-world operational water management applications. Um, so we can say that we must avoid artificial assumptions that the build natural and social systems that define our watersheds are independent. Recent innovations in information processing, uh, optimization, simulating, and management should be used to provide as broad a range of plausible water future as possible to better diversity our knowledge and decision making. Constructive decision aiding can be viewed as a process of collaborative learning and negotiation that can exploit diversity in evaluative perspectives and objective to identify alternatives that capture a broad suite of system behaviors relevant to both modeled and unmodeled objectives. Our models must provide a diversity of hypotheses and convey knowledge as broadly as possible to stakeholders, decision makers, scientists, and engineers. Um, at least, I want to say that we must bridge the growing gap between water management and water cycle science by coupling our observations and predictions to their um, social contexts, and by collaboratively constructing um, a diverse range of sustainable management alternatives to aid water resources decision making in the future. Hopeful it is useful to you for thinking about water resources management. Thank you.